contact, bearing 290. Sierra 22 is confirmed.
Acknowledge. Deploy the ROV.
Target identified. Boeing V-22 Osprey. Bureau number 166487.
Engineering submersible examining Boeing V-22 Osprey engine nacelles frozen in conversion position between helicopter and airplane mode. Checking tilt-rotor orientation.
Deep Sea Team surveying Boeing V-22 Osprey airframe integrity, examining crash impact damage to fuselage belly.
Checkpoint 100 activated, all green lights on the forward fuselage.
Roger that. Preparing tension on the main slings.
Attention, unauthorized vessel. You are in a restricted military zone. Cease photography and exit the area immediately.
2 heavy lift vessels positioning in formation above Boeing V-22 Osprey. Computer system.
All units, convoy is secure. Continue transit to destination waypoint.
Bridge, this is Port Control. You are clear for berth 49.
Roger that, Port Control. Approaching the pier now. Applying protective covers over Boeing V-22 Osprey rotor blades, shielding composite materials from UV and weather.
All right, team, listen up. This V-22 restoration is classified. We're initiating phase 1 on the tilt.
Make sure you're gentle on the composite skin here.
I'm almost done with this fitting. The corrosion was pretty deep.
Carefully cleaning 6 Boeing V-22 Osprey prop rotor blades. Composite blade structure delicate. Removing marine deposits. Washing Boeing V-22 Osprey engine nacelles. Cleaning inlet cowlings, exhaust systems, nacelle tilt mechanism.
Cleaning Boeing V-22 Osprey landing gear assemblies. Removing rust from struts, bogies, wheels, hydraulic actuators, brake assemblies.
Flushing Boeing V-22 Osprey fuel system, removing contaminated fuel, cleaning tanks, lines, pumps, filters, preparing for system restoration.
The salt water clearly caused degradation and delamination in the graphite epoxy.
We are testing the structural integrity and moisture content now.
The saltwater exposure caused significant delamination here.
Yes, the graphite epoxy is showing unique corrosion patterns.
Examining the Boeing V-22 Osprey engine nacelles, the inlet cowlings are damaged, and the nacelle tilt mechanism is frozen at 75 degrees.
Here, examining Boeing. Examining variant Boston Fort Osprey, tailless laborial stabilizer, twin vertical stabilizers at wingtips. Engineers examining Boeing V-22 Osprey composite fuselage skin, graphite epoxy construction, different from metal aircraft. Vehicle Schwartz, pumps, actuators, Boeing V-22 Osprey cabin pressurization and air conditioning systems, environmental control unit, ducting. The ultrasonic readings look good here. Cross-reference that with the load-bearing data on the tablet.
This reading confirms the hydraulic failure. Check the torque settings on the starboard nacelle.
Reading green across the board, moving to hydraulics.
Cross-reference this serial with the maintenance log.
The configuration details here are non-standard for this model block.
Installing additional supports under Boeing V-22 Osprey wings and engine nacelles, preventing wing droop, supporting nacelle weight, and careful load distribution.
Planning removal of twin Rolls-Royce T406/AE1107C turboshaft engines from Boeing V-22 Osprey nacelles.
Check the pitting right here. That's definitely saltwater corrosion.
Confirmed.
Confirmed.
I'm documenting it now.
Torque reading is stable at 250 foot-pounds.
Confirmed. The fuselage attachment points are secure according to the specs.
Rebuilding Boeing V-22 Osprey rotor hubs, swash plate mechanisms, blade grips, pitch control systems, precision bearings, and bushings.
Complete overhaul of Boeing V-22 Osprey transmissions, planetary gearboxes, cross-shaft interconnect, new gears and bearings, precision assembly.
Rebuilding engine mounts inside Boeing V-22 Osprey nacelles, vibration isolators, mounting structure for Rolls-Royce engines.
Restoring Boeing V-22 Osprey interconnecting drive shaft, allowing both rotors to operate if one engine fails, shaft running through wing, couplings, and bearings. We've accounted for the water weight. The 70-ton load is balanced. Yes, the wing carry-through structure is solid. Latches are secure. Confirm seal integrity.
Confirmed. Proceeding with the operational check.
Restoring Boeing V-22 Osprey cabin floor, cargo floor reinforcement, seat track mounting, floor panels, load-bearing structure.
This is where the actuator attaches. Make sure the sequence is followed exactly.
Got it. Hitting the required torque now. The trim tab clearance looks good. Easy, lower it slowly. We're almost aligned with the mounts.
Confirmed. Grab the high torque wrench. I'll start the connections.
Hold it right there.
We're clear on the output shaft.
Bring the cross shaft in.
Examining Boeing V-22 Osprey internal fuselage frames, composite and metal hybrid structure, checking frame integrity, reinforcing damaged areas.
The twist measurements look off near the root. What's the structural integrity like?
We're seeing delamination here.
Yeah.
So repair isn't feasible. We're looking at a full replacement.
Examining Boeing V-22 composite large skin for delamination, water damage, impact damage.
Patching damaged areas of Boeing V-22 Osprey wing skin, composite repairs, maintaining aerodynamic profile, fuel tank integrity. Rebuilding Boeing V-22 Osprey sponson structures, composite construction housing landing gear and fuel, restoring internal compartments. Restoring the V-22 landing gear requires meticulous attention to the hydraulic lines and structural attachments.
Make sure the adhesive cures properly on the seal system before we cycle the ramp.
Got it. I've logged the batch number on the tablet. Torque on the rivets is within tolerance. Structural integrity restored.
Confirmed. Let's sign off on the horizontal stabilizer.
Restoring or replacing Boeing V-22 Osprey V-22 Osprey balance composite blade construction requirement.
The FTIR readings here match the degradation profile.
I'm showing hydraulic contamination at the swivel joint. We should sample it. Examine Victoria incoming spread me.
Examining the V-22 fly-by-wire flight control system and triple redundant computers.
The bore scope shows some minor internal corrosion near the vent line.
Okay, logging that now. Are the crash-worthy tanks secure?
Surveying Boeing V-22 Osprey electrical systems. Generators on each engine, batteries, distribution panels, miles of wiring, complete rewiring.
Reservoir levels are stable. How's the pressure on the return line?
Holding steady at 3,000 psi, we are good to go.
Checking Boeing V-22 Osprey landing gear sponsons on fuselage sides. Sponsons house retracted landing gear, also contain fuel.
ECU is humming nicely. What are the pressure readings?
Looking good. All green on the diagnostics?
Perfect, button her up. Installing complete fuel system in Boeing V-22 Osprey. Pumps, valves, lines, fuel management computers, crash-worthy tank connections.
Installing hydraulic systems for Boeing V-22 Osprey, landing gear extension/retraction, nose gear steering, brake systems, anti-skid.
Power failure simulation complete. Start the manual override procedure.
Engaging the hand pump. Pressure stabilizing. Are these seats aligned with the brackets?
Almost, just need to secure the last bolt here. Torque on the SATCOM mount is set.
Roger that. Checklist item 402, complete.
All right, put on the main gear bogey now. Check the brake assembly now. Check the brake assembly closely.
Torque is confirmed on the main gear. How is the pressure holding?
Steady across the board, initiating the retraction sequence now.
Smooth travel and locked. Excellent work.
Examining Boeing V-22 Osprey aft cargo ramp. Hydraulic actuators, hinge mechanisms. Ramp designed for rapid deployment.
Installing proprotor blade fold mechanisms on Boeing V-22 Osprey, allowing blades to fold for storage, manual, or powered operation.
Documenting Boeing V-22 Osprey defensive systems, missile warning systems, chaff/flare dispensers, infrared countermeasures, classified protection equipment.
Precision balancing of Boeing V-22 Osprey proprotors, dynamic balancing, vibration analysis, critical for tilt-rotor operation.
Final torque applied to the hub bolts.
Roger. Initiating balancing sequence. Stand clear of the rotor arc.
Painting Boeing V-22 Osprey in military gray scheme, Marines green gray or Air Force gray, applying low visibility markings, national insignia.
Engaging Boeing V-22 Osprey prop rotors for first time. Rotors turning, checking vibration, tracking, blade pitch control, tilt rotor operation.
inversion initiated, passing the 50-degree mark. Systems appear nominal.
Steering checks complete. How do the brakes look from your end?
Solid stop, uniform pressure, clear for ground idle checks.
Lifting off now, stability check initiated.
Roger, slight correction on the yaw. Testing control response, lateral movement.